Welcome back to my channel and to my SSCE mathematics series from zero to guru. In the last class, I explained what is modular arithmetic, and I explained that modular arithmetic, so I also call the clock arithmetic, that is a system of arithmetic that wrap up after they reach a certain number. And I told you, for example, if you divide an integer by a number, then what you are going to have as reminder are those numbers between 0 and that number minus 1. So such number, for example, if you divide by 4, then you are going to have numbers between what? So when you divide by 4, you are going to have number between what? 0 up to 3. So these integers, so they are set of what? They are known as residues under modulo 4. And I said in general that if you are working in modulo n, then your residues must be set of number between 0 and h and n minus 1. Also, I explained what congruency means and equivalency of two integers. That is, two integers a and b are said to be equivalent or congruent to each other when they have the same remainder under the same modulo. And I gave you in general that if a and b are equivalent, or they are congruent to each other, then a minus b will give you a number which is a multiple of what? Of the modulo you are operating. Today, I'm going to continue with basic operation in modulo arithmetic, and I'm going to start with addition. Addition in modulo arithmetic is not difficult. So what you have to note is that you are working in a modular arithmetic or in a particular modular arithmetic, and you must have a certain number which are the residues in that particular modulo. So for example, if I'm working in modulo 5, then at the end of the day, I must not have 5 or numbers that are greater than 5. So then I must have numbers residue between 0 and h, between 0 and 5 minus 1, so which is 4. So for you to do addition in modular arithmetic, it is very simple. You can do that in two ways. Let me give you an example to explain what I'm trying to say. Example, evaluate 14 plus. So don't say plus. If you say plus, then you've abused the symbol, then you have to put this. So that they know that it is not a usual addition. You understand now? So modulo 5. If it is a usual addition, 14 plus 20 will give me 34. And can you write 34 in modulo 5? No, because I've said the other time that if you are working in modulo 5, then what you must have must compose of number between 0 and h and 5 minus 1, which is 4. So if you now want to do this kind of number, you can do it in two ways. So solution. First method is to add these two numbers together. Then when you now get the result of their addition, when you get their sum, you now convert the number back to what? To modulo 5, or to the modulo you are asked to work with. So 14 plus 20 will give me 34. You understand now? Then you now say, since we are working in modulo 5, then you have to convert this back to modulo 5. And you can do that by dividing by what? By dividing by, this is mod 5. So then you now say 34 divided by 5, and you write the remainder. Don't forget I said modulo arithmetic works with what? With only the remainder. So then you say, how many 5 are you going to see in 34? 5 in 34 is what? Is 6, remainder 4. Then you can say 14 plus 20 is congruent to h 4 in mode what? In mode 5. So you will observe that we've reduced it up to what? Up to a number that falls between residues of what? Of modulo 5. So, but another method you can use is number 1. The second method is to what? So I have 14 plus 20. what you can do is to convert this to modulo 5, convert this to modulo 5, then at the end of the day you add the two guys together. For example, don't forget 14, okay, you have mod 5. So 14 in modulo 5 will give me what? 14 divided by 5. So then you can say this is 20 divided by 5. Don't forget you have to write the remainder. This will be 4, remainder 0. And this will be 2, remainder 4. Since you are going to write the remainder, then you take out the remainder. 4 in this case, then plus 0 in this case. What do you have at the end of the day? You can see you have mode 4 in mode 5. Don't forget to put your modulo. You can see it is as simple as this. Let me give you another example. So you have 69 plus, don't forget it's not a usual addition. You have to put that to distinguish that, unless except you want to abuse the symbol. So you have mode 4. So since we are working in mode 4 here, you can use any of the method, but I'm going to use one here. What we could do is to add the two together. So if you have 69 plus 22, you know I have 1 here, remainder 1. This will give me 91, mode 4. But since I'm working in mode 4, then my residues are number that are composed of number between what? Between 0 and 3. Then I must not have 4 or number greater than 4. Then I have to convert this one back. You can do that by dividing by 4. And see how many 4 are you going to say? 9. That's 2. Remainder what? Remainder 1. 4 in 11. So 4 in 11 is 2. Again, remainder what? Remainder 3. Then you are going to write your remainder. So then you can say 69 plus 22 is equivalent to 3 in what? In modulo 4. So equivalent to 3 in modulo 4. This is very simple. This is how you are going to do it. If I were you, I will try the second approach too. But before I proceed, there is another question here. Number 3, construct addition tables for modulo 4. So when we say addition table for a particular modulo, I mean it's a set of all possible pairs of addition you can have in such modulo. You understand now? And you can get this by putting your addition here. Don't forget we are working in modulo 4, then my residues are number between 0 and what? And 3. That is 0, 1, 2, 3. Then you have your 0 here, you have your 1, you have your 2, you have your 3. Don't forget I said when you say addition tables for modulo 4, that is the set of all possible pairs of addition you can have in that particular modulo. You have 0, 1, 2, 3 here as well. Then you can start your normal addition, taking note that you must not have a number that is what? That is greater than 3, that is greater than 3, since you are working in modulo 4. Let us start. Then you can just add this column with this column. So 0 plus 0, 0, 0 plus 1, 1, 0 plus 2, 2, 3. Likewise, 1 plus 0, 1, 1 plus 1, 2, 1 plus 2, 3, 1 plus 3 is 4. Are we going to write 4? We are not going to write 4 because 4 has exceeded the residue. So then you are going to convert 4 back. You are going to do this by dividing 4 by 4. This will give you 0. So 1 remainder 0, sorry. And don't forget we are interested in the remainder. We are going to put it down. 2 plus 0 as well, 2, 3. This is also 4. Don't forget if you divide by 4, your remainder will be what? Your remainder will be 0. 2 plus 3, that's 5. If you divide by 4, that's 1, remainder 1. You are going to write the remainder as well. 3 plus 0, 3. 3 plus 1, 4. On no account should you write 4 since you are working in modulo 4. So then you are going to divide by 4 and write the remainder. Likewise, 2 plus 3, like we've done the other time, is 1. 3 plus 3 is what? Is 6. 6 divided by 4 will give me 1, remainder 2. And that's your addition modulo 4. Addition tables for modulo 4. If you want to do modulo 6, it is very simple. Then you have to do the table like this. You put your addition here, you write 0 up to what? Up to 5, since you are working in modulo 6. So ditto to these two and you had it. So I want you to try that. You can put your answer on the comment section. Please, if you like this video, don't forget to subscribe, share and like it too. I will meet you in the next video where I'm going to teach you how you can subtract in modular arithmetic. Thank you.